Okay, more notes from section 7.3, and this is example 5B. And we're going to take the same region that we had in 5A, except now we're going to revolve it not about the line x equals 6, but about the line x equals 8. Okay, so now we're going to have an offset here, so we're going to have a hole in this revolution, so we're going to use the washer method. Okay, so it's the same region. So this was 0, 6, and we already solved it for x as a y squared plus 2, so we can use piggyback from our work there. And again, I checked the, there's my region, etc. And now I got to check my my radius, and now I'm going to have, again, it's going to be a washer method, so I'm going to have the large radius minus the small radius. Now this is going to be constantly, you know, a big cylinder, so it's just like I'm going to take this, a bigger dome, or top of a, it could be the top of a looks almost like it could be, if we revolve it around, be the top of a sphere. And then if we took a sphere and we sliced off the top of it, we get this nice round object with a flat bottom, kind of like a dome, a big gigantic dome. And then if we drilled a hole down the center of it, we would have this big cylindrical part that we're pulling out. So that's going to be the minus pi r squared. So this is going to be the big part minus the inside part, gives me the what's left over, which is this revolved about this line, x equals 8. Okay, so now I got to figure out my big radius. So what's my big radius? What's this big radius going to be from here to here? That's the big radius. Okay, r. Okay, well, remember we could use right curve minus left curve. So the right curve would be what? The right curve would be 8. From here to here, all the way from here to here would be 8 minus from here to here. And that's going to give me this value, x equals y squared plus 2. That actually gives me the value of x that this is. So if I go all the way from here to here, that's going to give me the x value. So this whole distance from here to here, which is 8, minus that distance will give me that, which is my big radius, my capital R. Just darken that in, Okay, so there you go. Okay. And I have that over here. So big R, and this is my washer technique, and I can factor out the pi. So I've got big R minus little r. So the big R would be the right curve, which is 8, minus the left curve, which is y squared plus 2, and that's all in terms of y. And then the little r is this, and this is going to be constant, and this is just going to be this distance from here to here, which is the right curve, which is 8, minus the left curve, which is 6. So what's 8 minus 6? 8 minus 6 is 2. And that's constant, 2. But we could write it down here, right curve minus left curve, right curve minus left curve. Okay? Now on the big R, you can check this when y equals 0. If I put 0 in here, I get 8 minus 2 is 6. So when y equals 0, my radius is 6. That makes sense, my big radius. And then y is 2. If I put 2 in here, 2 squared is 4. 4 plus 2 is 6. So 8 minus 6 is 2, so I get the radius is 2, and that makes sense because the radius would be here 2. The big radius would be 2. Okay, that's the distance this curve is from my axis of rotation. Okay, so everything checks out. So hopefully you see how we got this. And again, the easiest way to do it is right curve minus left curve when we're using dy. It's top curve minus bottom curve when we're using dx with respect to x. Okay? So this technique's very helpful. Okay? All right, so once we have this set up, the rest is just, mechanics, that's all. Okay, so this is the hard thing. And sometimes they just ask you to set this up on the AP exam and not even work it out. They just want to make sure you know how to set these things up. Because the rest is mechanics, and that's the easy part. Okay, so 6 minus y squared plus 2 is, 8 minus y squared minus 2. 8 minus 2 is 6, so that's 6 minus y squared. 8 minus 6 is 2. Then I can square these both out. Again, I factored out the pi, and I'm going from 0 to 2 because this is with respect to y. Put a 0 here. I've been a little lazy on that stuff lately. Okay, 0 to 2. Okay. Okay, so this is going to be 36 minus 12y squared plus y to the fourth minus 4. 36 minus 4 is 32, so that's what we've got. Then we take the antiderivative, so we get 32y minus 12y cubed over 3, y to the fifth over 5, from 0 to 2. And again, our zeros zero out. That's nice. So I just have to take pi times this evaluated 2. 32 times 2 is 64. 3 goes in there 4 times. And then 2 cubed is 8. 4 times 8 is 32. And I got 32 over 5. 64 minus 32 is 32 plus 32 over 5. And this one I did work out. 160 over 5 plus 32 over 5 is 192 over 5 pi. So there you go. So once you set it up, that's easy. It's just making sure that you understand how to find the big R and the little r. And this is a good example. I hope that all makes sense. Hope you got all that down on the bottom. But again, the diagram really will help you organize your information and find those. So that's what you want to do. And I didn't really bother to, I didn't label these separately, so I hope you can see that this is the big R. And there's your little r. Okay. Probably label those again. Big R here. And little r over there. Sorry about that. So I probably should have done those separately. Okay. So there's big R and little r. I hope that makes sense. Big R, little r. Okay. Hope that helps.